In this lesson, we'll talk more about vector equations and look at how we can use them in applications. All right, so we have two boats, and we know their starting position and also their velocity vectors. Represent the position of each boat as a vector equation. So if we had the position of A, the position is just going to be the starting point. The vector, the position vector of the starting point plus the velocity vector, a multiple of the velocity vector. And go ahead and write out the position equation for boat B. And what do then we need to be able to interpret these. So find the speed of boat A. So the speed of boat A, we need to find the velocity vector and then find the magnitude of the velocity vector. So it's just going to be the magnitude of the velocity vector, and that's 6 squared plus negative 3 squared. And using a calculator, we get that. The direction of boat B. Direction of boat B, we want to find the bearing, and we do that in terms of degrees. So boat B, we need the direction. Well, that's going to come from the velocity vector, and we find if we're going to go in this direction, we have horizontal component of 4, vertical component of 2. There's the velocity vector. We need to find theta. So if we look at this triangle, 2, 4, theta, we have to have, we know that tan theta is 2 over 4, and we could just do arctan of 1/2, and that is 26.565 approximately, and then we have to describe that in terms of a bearing. So the bearing could be described as east 26.6 degrees north, or if we just find the complement of 26.6, that'll be 63.4. We could describe it as north 63.4 degrees east. And do the boats collide? So they have to be in the same position at the same time. So let's look at, this is a little different than intersection of two lines, because when we have intersection of two lines, we have different parameters. But here they have the same parameter, which is time, and we want to see when. So if we have 3, 8, 4, 2, when is that equal to 6, negative 10? So when are these equal? And all we have to do is find out the time when the horizontal components are equal, or horizontal positions are equal, and then see if at that time the y values are equal also. So let's just look at the horizontal 3 plus 4t. When is that going to be equal to 6 plus 6t? So we're just taking the top row and let's subtract 4t and subtract 6. So t is negative 3 over 2. That says that the boats will have the same horizontal position at time negative 3 over 2. And this, we wouldn't talk about negative time, so this is just saying that the boats will never have the same horizontal position going forward in time. And we can't go back in time. So we could stop right there and say that no, they'll never have the same horizontal position because time would have to go negative. But with the procedure, we could just say, let's look at the time for the vertical positions to be the same. So we have negative 10 minus 3, 8 plus 2t. And we solve that equation. So let's add 10, subtract 2, and here we have negative 18 over 5. So that's showing that the y values will never be equal going forward in time. So the boats are not in the same location at the same time, and that means they won't collide. And here we're just going to do mainly some review of some concepts, but now it's with 3 dimensions. And for the vector form of a line, we have to have the position vector is equal to the position vector of the starting point plus the direction. So we know a starting point. It could be either one of these, and we just have to find the direction. So if we called this, remember that the vector from A to B is B minus A. And so if we want the vector from here to here, we just go this vector minus that vector. Oh, let's clarify. This notation is for a point, and these are not vectors. These are coordinates of points. But we just write this in form of vector, and then it's we call it a position vector for that point. So the direction is going to be one vector, the position vector of that point, minus the position vector of that point. So we have 1, negative 4, 6. There's the direction, and then we'll say that the vector equation is a point on the line, the position vector of a point on the line. So here's the position vector of that point plus the direction, a multiple of the direction. right, so here's the two position vectors. Find the equation of the line containing the point of this position vector and the point of that position vector. Pause the video and try that. So the direction is -4, 6, 3 and 1, 2, 5. The difference of the two, and we have -5, 4, -2. And then the vector equation is one point, the position vector of a point on the line, 1, 2, 5, plus a multiple of the direction vector. So when we just have vector equations of lines, we have different parameters, and now we're going to look for the intersection in 3 dimensions, and there's just a few concepts to add to finding the intersection in 2 dimensions. We still set it up the same way. We want to know when they have the same point. So this represents a location on the line, that's a location on the other line. When do they have the same points? So we set them equal, and let's make a system of equations with 6, -8t, and then 1, 4 lambda, 1 plus 4 lambda, 1, 2t, 1 plus 2t, and 0 minus 2 lambda, 3 plus t, 4 plus 3 lambda. And we'll call those equations 1, 2, and 3. We only have 2 variables and 3 equations, so we only have to use 2 equations to solve for the 2 variables. And let's just use equations 1 and 2. We have to create opposites to eliminate the t, or we can create opposites to eliminate the lambda. Let's do the lambda. And to do that, we would multiply this equation by 2 to make a -4 appear there. So I'm going to copy equation 1 and multiply equation 2 by 2. So there'll be a 2 and a 4, and then 0 minus 4 lambda. We add and we get 1. This will be -4t and 8. All right, t equals 7/4. Let's find lambda, and we would use equation 1 or 2. Let's go ahead and use equation 1. So equation 1, we're going to substitute for t, and now we solve for lambda. Reduce the 8 and the 4, so that'll be a 2 times 7, 14. -8. We get negative 9 over 4 is lambda. So we want to make sure that we don't say that the solution or the intersection is 7/4 and negative 9/4. Now we need to check to see that using these values of the parameters, these values make the first two equations have the same value, but we need to know if the parameters will make this equation also have the same value. So we have to check in equation 3. 3 plus t is 7/4. Is that going to be the same as 4 plus 3 times lambda? And we have 19. This will be 12 plus 7 is 19 over 4. Here we have negative 11 over 4. These are not equal, so we have no intersection. If these were equal, if the parameters made equation 3 true, then there would be an intersection, and the intersection would be, we would just take t as 7/4 and substitute it into the original, evaluate everything, and that'll be the intersection of the two lines. If there's no intersection, then we can find out if the lines are skew or parallel. So we know that if they're not parallel, then they're skew because they don't intersect. So to see if they're parallel, we take the direction vectors. We want to know if these direction vectors are multiples of each other. So we're going to say is negative 8, 2, 1 equal to a multiple of 4, negative 2, 3. So those are the direction vectors. And then we just check negative 8 equals 4k, 2 equals negative 2k, 1 equals 3k. If we get the same value of k for all of them, then the vectors are parallel. But here we have negative 2 for k, here we have negative 1. So just by doing that much, we know the vectors are not parallel, the lines are not parallel, and that means they're skew. So not every non-parallel lines are skew, because if they intersected, then we wouldn't call them skew. And we'll stop there for this lesson.